Currently you're watching video E4.p2-24, which is the Station Model Lab. The learning target for this particular lab is interpreting a weather map to describe exactly what the current weather conditions are, and then with the potential to predict exactly what's going to happen to the weather over the course of a 24-hour period. So the very first thing is, while you're watching this or after you get done watching this video, you're going to be asked to go collect a few lab materials. And as with everything that involves this particular learning target, E4.p2G, the first thing that we've listed as materials, or one of the things that we've listed, is the use of colored pencils, markers, and or crayons. And again, the combination doesn't matter to us, it's just a matter that you have more specifically the correct colors used to draw and label the specific things that you would find on a weather map, such as different types of fronts as well as high pressure and low pressure symbols. The second is you're going to need some sort of technology device, iPad, iPod Touch, MacBook Pro, Acer. All of those will work because you're going to be using a site called convertit.com, and I'll take you right to that site to show you what it looks like. And convertit.com is just simply a way to take any type of measurement and then convert it into something else. So for example, most of the things that you're going to be dealing with are going to be measurement conversions. So if you just simply click, and I'll increase the size of this so you can see it, measurement conversion right here. It's going to take you to one of these specific things, and really all you're going to do is you're going to measurement convert. And here you go. You're going to type in exactly what you want to convert from. Do not forget the units, as you can see examples that they've listed here below, and then what you want to go to, and again the unit that you want to convert to. So for example, if you're converting from Celsius to Fahrenheit, you'll want to type in the number 5 and then whatever you're going to measure it in. So if you're going to do it in Celsius and then you want to convert it to Fahrenheit, you'll type in those things as far as units go. Okay, so that's just a quick example of how to use convertit.com. But again, if you have further questions about the use of it, do not hesitate to talk with myself or Mr. Fuzak. A very simple site to use, but just if you do have any further questions, let us know. All right, the first thing, once you've gathered your stuff that you're going to jump into, is reading page 1 and page 2. And as I've noted here, bold and big in some cases, there's a lot of really important information that's found on those pages, and I'll point them out to you. Right here on page number 1 gives you just a brief introduction into the actual lab itself, talking about how people actually use station models and what they actually show. One of the examples that's given right here is an actual weather station model, which will tell you exactly what's happening with the weather. As you can see over here, you have the actual temperature, and you'll notice that for this one, it's temperatures in degrees Fahrenheit as an example. All right, you'll see the dew point, and again, degrees Fahrenheit is the unit of measurement. You'll see visibility, the unit of measurement is in miles, precipitation type, and this is just one example of many that are given for types of precipitation. All right, then you'll find wind speed, which is located here with the wind barbs to tell you an exact, if a whole feather, for example, equals 10 knots, a half feather equals 5. So a half would be the shorter one, the longer one would be 10, for a total of 15 knots. Talk about cloud cover, which is always found right here in the middle. And then barometric pressure. We'll talk about how to convert the barometric pressure, as you see here, to this specific number, 112, because they do not look the same, but it's just a simple mathematic calculation. The trend in the barometric pressure, what has actually happened over the last 3 hours is what you're going to find here. You're going to see the amount of precipitation that's also listed, and then the wind direction as well. So lots of different things there. On the following page, you will see, as I mentioned in page 2, lots of information. This is going to start by talking about how to measure air pressure, but then after measuring it, it's going to talk about how to convert it. So if a station model is 500 or more, or if a station model is less than 500. So that will tell you how to convert the actual measurement. The second part is past pressure. And again, this little section is going to talk about what has happened and why it has happened. So this again is just a simple example about how those numbers are actually written on the actual station model. Temperature and dew point, information that will be provided there. Wind, and again, when asked to convert, when you're dealing with a knot equals 1.85 kilometers per hour or 1.2 miles per hour. So 1 knot is equivalent to those two conversion factors. Cloud cover, and you'll see down here in just a moment, these are all the different cloud cover symbols. Precipitation, the different types of precipitation that can fall are listed with these, and there are more of these specific examples. If you do remember Activity 17, if you've done that already, and if you haven't, Activity 17 actually, which is interpreting weather maps, has a full page with all of these different types of precipitation symbols and weather phenomena that take place. This is just an example, enough to provide you some things to do for this actual lab. Okay, so once doing that, once you're going through page 2, I've provided you a list of questions that you can find here in the pre-lab section right here. Question 1, 2, 3, and then on the following page 4, 5, and 6. And they're going to ask you to do things such as convert measurements from knots to miles per hour, to observe an actual station model to take some information out, such as atmospheric pressure, and then converting it. So it's basically just a practice round for you to attempt to actually do some of the conversions and also looking at the station models to pull out some just general information. And then we actually get into the lab, which is found on page 3. The first part is, well, using the station models, and you'll notice that there are 5 of them, station 1, 2, 3, 4, and then 5. What you're asked to do is you are asked to fill in for each of these stations 1 through 5, what has actually happened with the temperature. So you get temperature, both in Fahrenheit and Celsius, the barometric pressure, precipitation type, cloud cover, wind direction, the wind speed in knots, and then the pressure 3 hours ago. What's the actual change in barometric pressure? So you're going to start by looking at this particular station model for one, and you're going to use all the information that you find within this actual station model to answer the questions below, and just simply fill out the chart. And you'll do that for each of the stations. The areas of struggle that we've noticed more frequently with people come in these forms. We see a lot of people who struggle with the conversion of temperature, Celsius to Fahrenheit, or backwards, Fahrenheit to Celsius. We also see that people have issues with the barometric pressure when you actually are asked to do the conversion from if it's below 500 or if it's above 500. We see people that also have issues with wind direction. Remember, you name a wind from where it came from. So as an example, if you had a station model that looked like this, I'm just going to do a quick drawing here, and you knew that this was north, south, east, and west, you know that the wind is headed off in this direction, which means it came from the east. So you always name a wind where it came from. So in this case, if this was the weather symbol that you were using, it would be an east wind, naming a wind from the direction it came from. Next part, some people don't usually have problems with this, but they tend to convert it into miles per hour. And you'll notice that the question is asking you to leave it in knots. And then the one that everybody seems to struggle with is the actual conversion of the pressure, what it was 3 hours ago. Remember, the number that you see on the actual station model, and I'll go to this specific example right here, that number, -30, is the change in atmospheric pressure over the course of 3 hours. So remember, if it's negative or if it's positive, you are either going to add or you're going to subtract that number from the current barometric pressure. And that current barometric pressure is what you have located right up here. So you're going to have to do a little bit of math, either adding or subtracting to get to that current, the barometric pressure, that it was 3 hours ago. The next step is part 2. Part 2 is now going to ask you to take the information that you find on this and then use it to actually to construct an actual station model. So again, you have your temperatures in Fahrenheit, you have your dew point, you have your wind direction and speed, barometric pressure, the cloud cover, and then the current weather conditions that are all taking place. So again, you're going to then physically construct, based upon the city, you're going to construct this weather station model for that particular site. Conclusion portion is simply just looking at a weather station model that actually includes some information other than just the station models themselves. It also includes fronts, cold fronts and warm fronts. And in this one, you're going to be asked to study the weather station, and you're going to write the letter or letters, there could be more than one answer, of the weather station next to each description of the weather conditions. So you'll read the description, wind northwest at 40 miles per hour, and then what you'll do is you'll look at each of these station models to figure out which of these has that particular weather phenomenon taking place. And there's station A, B, C, D, E, F, G, and H. So those are the station models, and then you have X, which is located up here. So you're looking for each of these weather phenomenons, wind at for A all the way down through here, G. Okay, then the last portion here is a question, shade in the area of the MT air mass. So we're dealing with a maritime tropical. So where exactly would the maritime tropical air mass be located? And again, if you don't know what a maritime tropical air mass is, you may want to go back to your notes on air masses to kind of do a quick refresher. And then number 6, the last of these matching questions. What I've provided for you is just a simple question or statement, and then what I'm going to ask for you to do is to match it, column A with something from column B. And as it says, you're going to write the letter of the item in column B that mostly relates to the statement that's made in column A. And here's a note. You may only use one of those column B answers one time when you're putting them in each of these. All right? So that will take you through pretty much everything else that you see here for the Station Model Lab. Should you have any questions, don't hesitate to ask myself or Mr. Fuzak for assistance.